Hello, this is Mr. Kinyanola. I'm going to show you how to find the area of this triangle. Now, you may say to yourself, this is super basic. I know how to find the area of a triangle. It's just base times height divided by 2 because a triangle is half of a rectangle. But look at it closely. Base times height divided by 2. Do we have the base? Yeah, we have a base. Do we have the height? If you guys do remember, height is always perpendicular to the base, and it doesn't look like we have the height. We have a third side, but we don't have a base in height. So I'm going to show you guys how to find the area of this triangle even without the height. So let's do a quick review. So area of a triangle is base times height divided by 2. It's divided by 2 because a triangle is half a rectangle. It's just a rectangle cut in half. And the base and the height are always perpendicular. So remember that. Two sides that are always perpendicular. So I'm going to highlight our base. I'm going to highlight our height. They make a square. Okay, so remember the area is always the number of squares that fit inside of a shape, and we're going to use the two sides that make up a square, the two sides that are perpendicular. But we don't have the side, so what are we going to do? Well, look, it's a right triangle. It's a right triangle. What formula do you know works with right triangles and only right triangles? Ha! Pythagorean Theorem. C squared equals a squared plus b squared. And c is always the hypotenuse. And look, we have the hypotenuse. The hypotenuse is 15, so I'm going to write 15 squared. One of our legs is 9, so I'm going to write 9 squared plus b squared, which is this other side. And then I'm just going to work it out. 15 squared is 225 equals 9. 9 squared is 81 plus b squared. I'm going to subtract 81 from both sides. 81 from both sides. And this is a 4. I don't know. Let's see, make that a 12. Borrow that. Make that a 1. 144. Okay, so equals b squared. And the opposite of squaring something, the antonym for squaring, the opposite is square root. So I'm going to square root 144. And our b equals 12, that missing side. We're not done because the question says find the area. We're not trying to find that missing side, but we're on our journey to finding the area now that we have this missing side. All right, so we use a Pythagorean theorem to find this missing side. Now we can use this formula, base times height divided by 2. I'm just going to substitute. So area equals 9 times 12, the two sides that are perpendicular to each other, divided by 2. Let's go. 12 divided by 2 is 6, so 9 times 6 is 54 feet square. There's our final answer. So 54 little squares fit inside of this triangle. Let me show you another example, a slightly more challenging example, but the same concept. This one right here. So everyone look at this one. We have a side, and we don't have the other side that's perpendicular to it. So we can say we have the height, but we don't have a base. We have a hypotenuse. So we're going to do the same thing that we did in the other problem, but don't skip, don't scroll forward, okay, don't fast forward. Keep on watching because this one's slightly more challenging. So c squared equals a squared plus b squared. Our c squared is 16 squared. Our a is 4 squared plus our b squared, that missing side right there, the side that makes a square with the other side. That's what we're trying to find. 16 squared is 256 equals 16 plus b squared. I'm going to subtract the 16 from both sides, which is a 0, a 4, and a 2 equals b squared. Yikes! I'm going to square root both sides, and I don't have a whole number that makes 240 to multiply it by itself. So let's do some of this quick math. So let's go 24 times 10. So I'm going to use a factor tree to find my pairs. I'm going to do 4 and 6. And I'm going to do 2 and 5. I'm going to do another 2 and 3 and a 2 and 2. I'm sure if I start off with other numbers, I could have had a much smaller factor tree before finding my pairs, but here we are. We're here. So I'm going to circle my pairs. So I have a pair of 2s and I have another pair of 2s. So the square root of 240, so our B, is 2 times 2, which is 4. And our leftover leaves is 3 times 5, which is 15. So the square root of 240 is 4 square roots of 15. Now, there's our base, 4 square root of 15. But we're not done. This question doesn't ask to find the missing side. It says find the area. So now we're going to substitute into our formula area equals base times height divided by 2. I'm going to write 4 square root of 15 times 4 over 2. Whoa, this gets a little tricky. So what I'm going to do is, I'm going to, as I've done, I try to make numbers smaller. So I'm going to divide 4 and 2. So I'm going to get 4 square root of 15 times 2, because 4 divided by 2 is 2, and that gets rid of that 2 in the denominator. Then I'm just going to multiply the numbers on the outside, these coefficients on the outside. So 4 and 2, 4 times 2 is 8. There's no radical to multiply this radical 15 with, so it's just radical 15. So 4 times 2 is 8. Square root of 15 doesn't multiply with another square root, so it's just square root of 15. Feet squared. So there is our answer right there. So I use the Pythagorean theorem. I found my pairs to find the base, multiplied it with the height, and then 4 times 4. Oh, did I? Oh, yeah, yes. Never mind. I'm freaking out. I thought I messed up, but I didn't. Yeah, I didn't multiply first. I divided to get that 2. And then 4 times 2 is 8, square root of 15. Okay, so that was me freaking out for no reason. So, call myself. Sometimes I freak out. All right, one last one. This one, find the area of this isosceles triangle. Again, base times height divided by 2. This is a tricky one. Look at this one. You just have to be able to see things that you need and do the right steps using what you have. So remember, the base and the heights are perpendicular. There's no side that's perpendicular. There's 14. There's no side that makes a right angle with that. This is also 14. I'll just put that in there, okay? Because it's congruent to these little tick marks. One thing that this problem that I forgot to put in there was that this right here, though, is a right angle. It bisects it, so I should have put that in there. So problems that you see in the future, it should have a right angle on there. Okay, so if this is a right angle, if you remember from a previous video that isosceles triangles are just 2 right triangles, just a right triangle that's reflected on the other side. So here's our right triangle right there. Okay, so we have a right triangle. We have a formula. We have a theorem by a guy named Pythagoras, who discovered it, since he discovered it, he got the naming rights for it. So the Pythagorean theorem. We have our 20, which is our base. We need our height right there. But this right here isn't a right triangle. This right here is a right triangle. This is not. This is not a right angle. This isn't a right angle. This isn't a right angle. But this is a right triangle because that's a right angle. So we're going to focus on this triangle right here. So this line right here, this height, bisects this 20. Bisects means it cuts it in half. So that means this side right here is 10. This side right here is 10. And we're going to focus on this triangle again. So this 14 in this right triangle is our hypotenuse. It's opposite to the right angle. So I'm going to go 14 squared equals 10 squared plus the side that we're looking for, this side right here. Okay, and then I'm going to multiply. 14 squared is 196 equals 100 plus b squared. I'm going to subtract 100 from both sides, which is 96 equals b squared. Then I'm going to square root both sides. Then it doesn't seem like 96, there's a square root that's just a whole number. So let's break it down. I'm going to, I think I could go 4 and then 24. 4 and 24 make 96, yeah. So, and then I'm going to do 4 and 6 and 2 and 3. I'm not going to factor these 4 some more because I have 2 4s. I have a pair right here. Now, if you found some other ones, okay, to start off with other than 4 and 24, then hopefully when you find all your pairs, you'll get that the square root of 96 ends up being 4. And then 2 times 3 is 6. 4 square roots of 6. Okay. So it turns out our height is 4 square roots of 6. Now we're going to find the area of this entire triangle. We have our entire base. Okay, to find our height, we cut it in half because we wanted a right triangle. Now we're going to go back to this triangle, which isn't a right triangle, but we used half of it to get a right triangle to get its height. So now we have our full base, which is 20 times 4 radical 6 over 2. And so 20 divided by 2 is 10 times 4 radical 6. 10 times 4 is 40. And there isn't a radical to multiply this radical 6 with, so it just stays the same. So radical 6 units squared. Woohoo! That's it. So that's how you do it. If you have a triangle and you don't have one of the base, if you don't have a base or a height, but you have one of them, one out of the two, try to get a right triangle from there to get the other one using the Pythagorean theorem. All right, hopefully that was helpful. Have a great day.